Today we are going to perform open circuit test on a single phase transformer in our electrical machine labs. This test is conducted to determine equivalent circuit parameters. These parameters includes magnetizing reactance XM and core loss resistance RC. This test is performed on LV side of single phase transformer and the HV is kept open. So for conducting this test in lab, we required single phase transformer. Here we are going to consider 1 kVA 230 volt oblique 115 volt transformer. We need one AC ammeter that would be of range of 0 to 1 ampere in one number, AC voltmeter 0 to 150 volt one number. We need another AC voltmeter 0 to 300 volt in one number. We need a wattmeter range of 150 volt 5 ampere in one number. We need a dimmer stat or continuously variable auto transformer for varying the supply. It would be of single phase 0 to 260 volt range one number, and we need connecting wires. So let's see the equipments. So this is the dimmer state. It has two terminals. You can see by varying this knob we can set appropriate voltage. Then we need a AC ammeter. So this is the AC ammeter. It has three ranges. So you can see it here. It is 10 ampere, 3 ampere, 1 ampere, and there would be one common terminal. So and here is the wattmeter. Wattmeter has basically 4 connections. So let's see what are those connections. So this is the wattmeter. You can see it. It has 4 terminals: M main, L line, C is the common, and V is the volt. So you'll find these terminals here: M, L, C and V. For V there are 3 ranges: 150 volt, 300 and 600. There are also 2 ranges. This wattmeter is designed for 2.5 ampere when the connections are connected like this way. So you'll get 2.5 ampere, and when it is connected, this steel connectors are connected parallelly. At that time we are going to get higher range. So that would be of 5 ampere. Okay, then here is a single phase transformer of rating is 1 kVA 230 volt 115 volt. It means it has 230 volt. HV is of 230 volt and LV is 115 volt. These LV and HV connections are brought out here, that is extended here. You can see it. There are 2 terminals and for LV, and there are 2 terminals for HV, and we are going to use multimeter as voltmeter. So let's see the connection diagram for open circuit test. We can see there is a supply that would be given to the dimmer state. From here the 2 terminals are coming. So one terminal is connected to the one terminal of voltmeter, and the another terminal of voltmeter that would be connected to the second terminal of dimmer state. Then from here one terminal would be connected to the ammeter, common terminal of ammeter, and the other terminal that would be given to the main of wattmeter. Then the terminal from L that would be connected to one of the terminal of LV. So let us mark at terminal 1, and the other terminal of LV that would be connected to the V and LV. So one wire would be connected between V and the other terminal, the second terminal of LV. And you can see this M and C that would be short. So we will short this by a connecting wire. Then one of the LV wire, the second terminal of LV, that would be connected to the other terminal of dimmer stat. So we can again mark here, give some, it is 2, and we can say it is 1. Okay, so and the HV that will be kept open. If we want to measure the voltage across HV. So we can connect one voltmeter of range 0 to 300 volt, and here the range of voltmeter that would be of 0 to 150 volt. Okay, so this is the connection diagram. Let's see, make this connection on the equipment. So here is the demonstrate, and the demonstrate that would be connected to the AC supply. So this is the input terminal for demonstrate. Then output that would be taken from these two terminals. So one of the terminal from demonstrate that has to be connected to ammeter. So we are connecting this terminal to the ammeter, and that would be connected to the common terminal. So here we can see it is the common terminal. Okay, and the other terminal from ammeter that has to be connected to main. So this is the other terminal from ammeter, and it has to connected to the M terminal of wattmeter. So see, it is the M. So we have connected one wire from ammeter to main terminal of wattmeter. Then the L is connected to the first terminal of LV of transformer. So here is the L, and we have connected one wire here, and this has to be connected to the first terminal of LV. So here are the two terminals which are brought out here. So we are connecting to this terminal. Then just see the connection. We have sorted out M and C. So here is the M terminal, and this is the common or C terminal, which is sorted by one connecting wire. Then in other connection, the V is connected to the second terminal of LV. So here is the V. We are going to use 150 volt range. So one wire is connected over here, and in other terminal of LV, that is the second terminal, is this one. So we are connecting over here. Then we can observe that the second terminal of LV, that is also connected to the second terminal of the dimmer stat. So this is the second terminal of dimmer stat. So we have connected one wire here, and then it is connected to the, you can see now we have connected this wire to here. So this is the another connection. So in this way we can make the connection, and before switching off we need to verify the connection. So let us verify what should happen. One connection from the dimmer stat, that should be connected to the ammeter, the first terminal of ammeter. So it is connected over here. Then from other terminal that would be connected from ammeter, that would be connected to the main of wattmeter. So yes, it is connected over there. M and C should be shorted. So we have shorted M and C. Then from L, it should be connected to the first terminal of LV. So here it is connected, it is fine. Then the V, it should be connected to the second terminal of this LV. So that is connected, and one terminal from second terminal of dimmer state or variac, that is should be connected to the second terminal of transformer. So yes, it is connected. Now we have not connected any voltmeter here, so we can use multimeter for this purpose. So we are going to switch it on, and we will make it AC. We need AC meter, and the range selection is kept on auto. So and the probe should be on voltmeter, and this should be common. The positive should be connected to the positive port, and negative one should be in the negative. So connections are all right, and now we can switch on the supply. Okay, so let's switch it on, and then we are going to see the reading. So we have make it switch on the supply. So now supply is switch on. This test is performed on rated LV voltage. So we need to set voltage by varying this to 115 volt. So this is connected. You can observe that okay, there is some deflection in ammeter, as well as we are getting some deflection in wattmeter. So needle is moved from its zero position. Please remember, do not touch any live wire while conducting this test or while taking the reading. So we are going to measure the open circuit voltage across LV. So here let's see what is the voltage across LV, and it is 114.9 or 8. So we need to set this using dimmer state. So we have set this using dimmer state, and we need to note down the reading. So we will write this reading here in our observation table. That would consist of open circuit voltage. So it is 114.8, though it should be the rated. So what exactly coming, we are writing it here. Then see the note down the reading of ammeter. This is 1 ampere ammeter. So we need to take reading of this upper scale. So it is 0, 0.2, 0.3 and 0.4. So the reading is 0.4. Noted down this reading here. So it is coming 0.4. Then note down the reading of wattmeter, and this is 10. Here it is 20, and there are 10 divisions. So reading would be the reading is here it is 18 watt. So note it down here, 18 watt. Now we have noted down all the readings, so we can switch it off and then we can do the calculation. So in calculation we are going to determine the value of magnetizing reactance using this formula, that is Xm is equal to VOC by Im. We have measured VOC here. So in this table just we can put the value of VOC here. The Im, that is the magnetizing current, it need to be determined. So it will be given by Im is equal to IOC sin phi OC. So IOC is measured from this test, and we can calculate the phi OC, that is the power factor angle obtained in OC test. So phi OC, that would be given by cos inverse WOC upon VOC IOC. So what is the WOC? That is the power measured from during this test. So that is with us. We have VOC, we have IOC. Substitute its value, do the math, you will find out the power factor angle. Then substitute its value here and substitute value of IOC here, you will get the Im. So Xm, that would be obtained using this equation. Now we will calculate the core loss resistance, that will be given by VOC upon IC, and IC is given by IOC cos phi OC. Already the power factor angle or power factor is calculated using this equation. So the power factor angle, substitute its value here, substitute IOC value from this table, and you have IC. So you can calculate the core loss resistance. So from this test we can calculate magnetizing reactance, core loss resistance. Okay, so we have today we have seen open circuit test on single phase transformer. Let's see once again the setup, how we have done this. And the important thing about this test is that we conduct it on LV side when secondary is open. The LV rated voltage and rated frequency is applied, and for this test we need transformer, ammeter, voltmeter, and power factor. For measuring power we need wattmeter. Okay, so it's all about this test.